Okay, recording. Math Tutoring Center. It's online this year. It's usually in person in LeConte. It's a free tutoring space. So if you have any questions on something, um, you can go there from like 10 to 3 every day during the week, and there's gonna be a grad student in there. I will be in there specifically on Tuesdays and Fridays from 12 to 1. So those are also technically my office hours, but they just won't be on Zoom. It's a little confusing. The MTC, like who's in there, is also on. If you just Google Math Tutoring Center U of SC, it's what I do to usually find the link. There's a Blackboard link and also a detailed like who is there if you forget like if when I'm working there. And I'm there from 12 to 1 on Tuesdays and Fridays. That's what TF means. All right. What are you supposed to do if none of those hours work for you and you want to meet? What should you do?
Email you.
Yeah, just email me and we can set up a time. I'm home all day. I do not leave. So I'm pretty available. All right. I just have 3 classes and this class that are the only things in my way. All right, cool. 7 of you, I think now have not joined our WebAssign class. Jaden's also right. Please join it. It's 20% of your grade. That would suck to lose that. Please join it. And if you're having trouble with it, email me and I can see what I can do, troubleshooting. And if I can't do any help, usually customer service is pretty good. The practice homework closes at 11:59. Remember, this is just not, I'm not grading this. This is just to get you kind of used to how to use WebAssign. You can also like figure out how to ask me questions. You can ask for an extension for this one if you just want to play with it a little bit more before starting homework 1. There's a way to do that. Just getting familiar with the platform. It's really helpful. So that's what, and to review the stuff that we went over. Your homework 1 will be assigned on Friday. Remember, homeworks come in 2 parts. Part A is on WebAssign like an A. And then part B is uploaded to Blackboard, like B for Blackboard. Part B is just going to be like 5 problems from the sections that we've gone over this week. So today and Thursday. I just want to, I'm making sure that you're like doing it correctly. So like, please show your work. Also, I'm giving you guys a chance to get extra credit on your first exam already. So if you can turn in homework B as one single PDF file, it can have multiple pages, that's fine. Your homework probably should be like a page or 2. I just want one PDF, not a JPEG, not 5 JPEGs, none of that. I honestly don't even care what you name it. You can, I usually would do like my last name. Okay, let's not write black. So like last name, and then underscore homework 1. That's usually how I name, and then it would be like .pdf. That's how I name my homeworks for my classes. I've had some professors request that you do it differently. That's because we email them. But I really just care about it being a 1 PDF because grading multiple JPEGs that are turned the wrong way is so annoying. It takes me so long to grade it, and I have a lot of you. So I want to get back feedback and grades to you as soon as possible. And then our to-do list today, oh, there's a picture of Duke. Cute little nose. We're going to finish 8.3 and start and finish 8.4. And I just remembered I needed to go over something that is covered on the practice homework. So we're going to do a quick review. Do you guys remember how we talked about if I wanted to represent the interval parentheses 1, comma 2 bracket? Oh yeah, the app that I suggest is called Adobe Scan. It's really easy. It's really great. And it'll make a PDF, and then you can like add, you can take a picture of it, and then I think you like add something to it, and it'll just add another page onto it. And then you can like email yourself the PDF or something like that. It's really great. Okay, cool. So if I want to write this on the number line, so say I have this really long number line and just keeps going. So let's put 0 and then 1 and then 2 right here. So let's draw it with this purple line. So I'm going from 1 to 2, right? But instead of doing something like this with these brackets, how else can I represent 1 and 2?
Points.
Yeah. Ronald, was that you? I forget who was talking.
CJ.
Oh, sorry. Yeah. How would you, people were saying open and close circle. Is that kind of what you said?
Yeah, like you use the close for like the bracket and then the open for parentheses.
Yeah. Right. Open circle for an open bracket, closed circle for a closed bracket. I think that's pretty intuitive. You can also think of like that open circle. If you guys have ever seen, and we'll draw functions like this too when you talk about, oops, I don't know what that was, continuous functions. If something's like this, and then it's like not quite there at that point, an open circle is also to represent the same as it is on a number line right here. So this notation is very useful, and it's also what WebAssign uses, and I completely forgot to do it because the book doesn't ever go over it. What color was I using? There it is. So open circle, open bracket, close circle, close bracket. You guys feel pretty good with that? Thank you. Okay, cool. I think that's all I wanted to say about that. So, oops, not that section. We were on A3. Okay, cool. So remember 8.3 is about integer exponents. Integers are whole numbers. We'll get to rational exponents. So remember rationals are fractions. Numbers that we can be represented as fractions. So we talked about how A is the base. Where's my pointer? That's not my pointer. Is my pointer? Yeah. So A is my base, and N I call my exponent or my power. Can go by both of those names. And it just represents multiple multiplications. And we also need to be careful about what my base is. So negatives, I can either group my negative into my base by including a parentheses, or by not including a parentheses, I'm saying the negative is not in my base. So I'm just multiplying 2 to the 4th times a negative. That's what that's saying, versus -2 is the base raised to the 4th power. Okay. So then we talked about negative exponents. So we talked about negatives in the base, and now we're talking about negatives in the power. Well, that just means it's not happy where it is, in my opinion. That's how I think about it. Remember, I drew a little house. A to the negative n was not happy there in the numerator. So it goes down to the denominator where it is happy. Also think of it like a reciprocal. I'm going to flip it. All right. And then we talked about how you can't divide by 0. That's no fun. Okay. So that was a little quick review, but this should be kind of a little bit mostly review. Let's keep going on with green. I really like dark green. It's a good color. Do I have any dark green? I have nothing. Okay. So properties of exponents. I know you guys have been dying to talk about this. So A, B, M, and N are just non-zero real numbers. So it could be 3.3 repeating. It could be 1. It could be -2/3, something like that, right? Remember, real numbers can be decimals repeating forever. Those are real numbers, and they're negatives. Just nothing, just can't be 0. So our first property is if I have two not terms, factors, they're factors if they're multiplied, and they have the same base, what do you guys think I'd do with those exponents if I just want to write it with one base? Right, Ronald, I'm going to add them. I almost wrote add. So it's going to be a to the m plus n. And you can think about that as just coming from the definition as we described it up here, right? A to the n is a times a times a, n times. So this is a times m times a times a times a times a times a, n times. So together, a times a, blah, 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 m plus n times, right? So number 2, instead of multiplying them, I'm going to divide them. Multiplication and division usually synced up together. So if I wanted to write this as one base, I would subtract them. So m minus n. Think about this as when you ever had like things that you can like cancel stuff out. I'm gonna cancel whichever number is bigger is gonna wherever a is. So that's why I get m minus n, the difference of the two. Does it matter which one I subtract from the other? Yes. Right. I think we all agree of subtraction. I can't 3 minus 1 and 1 minus 3 are two different numbers. So top minus bottom. Think of n is on the bottom. I can even write this as like a to the m times a to the negative n, and then just use a, right? By just bringing a to the n to the denominator, making it unhappy like I did up here, and then using property 1. These all intermingle with each other. It's pretty fun. Okay, this example is in my way. That was from last time. I don't know why it's going 1, 2, 3, 4, 5, 6. I think it's because there's a page break. So for number 3, now I have 2 different bases, but I have 1 exponent. So exponents the same, bases are different. So a times b, also just known as ab, to the m. Can I distribute that m? Yeah, I can. Okay, Ronald's answered enough of these, so he's not going to answer any more of them because he is showing off too much. Great. So that means I can distribute exponents over multiplication. And then we'll get to distributing exponents over division and what we can't distribute exponents over. It's okay. Okay, so number 4, I have a to the m to the n. So what this would look like is a to the m times a to the m times a to the m n times, right? So how can I rewrite a to the m to the n without parentheses? What do you guys think? Yeah, Chloe, you got it. We're gonna multiply m times n. So see up here, just an example. Usually you're just kind of like dot, 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 a to the m, just an example. N times. So I'm going to multiply them together, right? I'm multiplying a, m times, another m times. So it's like m plus m plus m. So I'm adding m to itself m 3 times. So a to the m times n. So that's where I get multiplication and exponents. Okay, so this property 5 is similar to property 3. Now my bases are not multiplied, they're divided. Who thinks that I can still distribute exponents? If it'll work similar to 3. Hannah Jane says she thinks so. Right. I can rewrite A over B as like A times like 1 over B to the M. And then I can use property 3 to say, oh, well, that's A to the M times 1 over B to the M. Do you guys know what 1 to any power is? If I just multiply 1 by itself again and again, it's just 1. Yeah, except for 1 to the infinity. For some reason, that's not 1. I wrote a college essay on that and I have some beef with it. But 1 to any other number is fine. So we have A to the M times 1, because that's just 1 over M, B to the M. What that all equates back to is A to the M over B to the M. So I can still distribute. Oh man, it was gonna make such a nice box. Oh, there we go, beautiful. I can distribute over division. Okay, great. Now I'm raising A to the 0 power. What do you guys think this is going to equal? It's going to equal 0. F equals 0. Jaden says 1. Okay. Whoever thinks it's 0, can you explain why you guys think it's going to be 0? So team 0. Hannah Jane, you cannot back out like that. So does anyone who thinks it's 0 want to explain why? Oh, sorry. Someone say something.
Oh no, I just said I'm sorry for backing out.
No, it's fine. So are you on team 1 now?
I am. I'm on team 1.
Why do you think it's 1?
I remember it from doing math with my math teacher. I don't remember why it's 1, but it really rung a bell.
Okay. Ronald, do you want to answer? I'll let you answer this one. And then no more. Okay, yes, I know it's 1, but why is it 1? Does anyone know why it is 1? But the base is A. Here, I'll show you guys how a fun way to remember it. Oh, yay, okay, good. Yeah, that's what like the beginning of this course is for, a good refresher. So remember how, okay, let's go look at 2. Let's use 2 to explain 6. So A to the 0 is the same as saying A to the M minus M, any number really, right? A can be any number, right? Remember, it's any real number. So it could be a decimal number, a fraction, anything. So if I think of A to the 0 as A to the M minus M, okay, everyone stop guessing. Then that would give me A to the M over A to the M using 2 up here, going like this way. Well, this is just something A to the M divided by A to the M, something divided by itself. What's anything divided by itself? Just 1, right? And that's why that's that. Right? Another way you can think about it, if I'm going like, let's do 2. So 2 squared, no, sorry. 2 to the first power is 2. 2 to the second power is 4. And 2 to the third power is 8. Well, I know how to do it going up, right? So I just multiply 2 each time. But to go backwards, opposite of multiplying by 2 is dividing by 2. So if I do 2 to the 0, right, to get from 2/3 to 2/4, I divide by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So I showed it to you using definitions and implicitly. Isn't that neat? Okay, cool. Oops, I just opened up the textbook. Son of a gun. Oh, that's what I want to open. Okay, cool. So then I wanted to work through a few examples. This one right here is what I was actually going to show you guys down here. So you can do even ends if you want it to be. Because this example says use the exponent properties above to simplify the each expressions. 6 is kind of like a little thing, hidden property. Some people just skip it over just like as like, remember this. That's like a lot of the way that teaching was when, at least when I was in high school. And I think now people are studying the art of teaching more. So I think there's been like developments on how they want people to teach. Okay, let's do some examples. I already did one for us. So 2 now, remember we are just simplifying these using the expression. So it's an expression because there's no equal signs. If there's an equal signs, it's an equation. So we're just trying to simplify it down. All right. So that usually means I just want one of each thing. So one base with one exponent. So now I have 3 bases, right? I have 3 to the 6 times 3 to the negative 2, all divided by 3. And if you just see a number all by itself, it kind of has like a hidden exponent of 1. All right. So what can be one of my first steps into simplifying this problem? There's lots of ways and lots of things to do first. Just want to hear from you guys. I would combine the top. Yeah. I usually like to focus on the numerator, then focus on the denominator, and then bring them all together. So let's do that. So I'm going to leave everything over 3. And then 3 to the 6 times 3 to the negative half. Sorry, not half. Negative 2. What would that simplify to? I'll give you guys time to type. 81. CJ, what if I want to leave that in base 3? Yeah, 3 to the 4th. It might be a little harder. The only reason I want to leave it as 3 to the 4th right now is because I'm not done simplifying. I don't know what 81 divided by 3 is right off of my head, but I know how to reduce 3 to the 4th over 3 a little bit better. Just, you're not incorrect. Just a little trying to save you more work down the line. All right, well, the denominator is already pretty simplified, so I'm not going to do that. Now I can combine my numerator and denominator. So what that means is I'm going to take 3 to the 4th times 3. Remember, this is 3 to the 1. So when I move it up, it's going to be 3 to the negative 1. Beautiful. And the reason I'm doing that is just because they're the same base and I know they're going to reduce. So, and then same with the numerator, I'm going to bring the exponents together. So that'll give me 3 to the 3rd, 4 minus 1. And I believe that is 9 times 3, which is 27. All right. Not too bad. Let's move on to one that's a little bit more fun. So now we have, here, I'll leave that there so no one else is still writing. Now we have in problem 3, 3x squared y cubed minus 4. Hold on, something just fell on the ground. Okay. We are good. Minus 4x to the negative 2, y to the negative 5. So I'll give you guys a second. Again, lots of different ways to do this. Who wants to tell me what they would do first? Distribute. Jaden, how would distributing look like? Things are multiplied now. So foiling, Abby, is when we're talking about factors. So like if I had like a plus b, c plus d, That's when FOIL comes, when I have this addition involved, but I don't have that right yet. And we'll get to actually talk about foiling in a few sections. No, you're fine. It's just terminologies that I want you guys to make sure. So when you say distribute, everything's kind of already multiplied, right? So I can almost kind of drop these parentheses and everything's multiplied. So I can just do 3 times x squared times y to the third times, I'm gonna put -4 in its parentheses just so we know that the negative is with 4 and it's not a subtraction. X to the -2, y to the -5. No, it's fine. It's kind of like the trouble of being online. So now what I like to do is multiply. I like to put my like terms next to each other. So like terms, x and squared and x to the -2, their bases are the same. So they're like terms. So I'm gonna have like 3 times -4. Let's say x squared times x to the -2 and y cubed y to the -5. Yeah. So I didn't really do anything other than just switch around who was multiplying in what order. Remember, multiplication is what we called commutative. A times B is B times A. Like you would commute to work. You can go one of 2 ways. And then I would simplify from there. 3 times the -4 is -12. What is x squared times x to the -2?
Isn't it 1?
Yeah, right, because it's going to be x2 minus 2, x to the 0, which is just 1, right? So it is just going to be 1. Good job. And then y to the third times y to the -5. What do you guys think that's going to be? Duke, stop. Y to the third times y to the -5.
Y to the -2nd.
Yeah, and how'd you get there?
You subtract or I guess, yeah, like you subtract 5 from 3.
Yeah, you said always have to say it backwards when you're talking about subtraction, and it's always weird. So, right, we did like x 2 minus 2, y 3 minus 5, and then that gave us x to the 0, y to the -2, and as we said earlier, x to the 0 is just 1, -2. There we go. So I don't really like answers with negative exponents. So I would not consider this simplified. Negative exponents, the variable is not happy. So how can I rewrite this so that it is simplified? AKA there's only positive exponents. Right? Yeah, I want to move y to the bottom. Duke, you need to stop. If there's like any truck noise or someone knocks at the door, he's all protect mode. But he is a pansy. The x is gone because we had x to the 0 power, which became 1. And right, Jaden. 1 times anything. The kind of, it's like a, you don't need to add or multiply by 1. You don't really keep a 1 there. I'm going to box this so that you're looking back on these notes, you know that that is our final answer. I usually like to box all of my number answers. Let me do that now. Sorry if you're writing.
So,
oh yes.
Question.
Yeah.
For that, like the one you boxed, does it matter if we keep it as that like -2 right there, or do we have to move it like how you did?
Yeah, this isn't, the negative exponent is not simplified yet. On exams, I say no negative exponents. I think WebAssign also says that, but I think it'll also let you kind of get away with negative exponents. Actually, no, it doesn't. So WebAssign doesn't even see negative exponents as simplified yet.
Okay.
So yeah, I used to be a little bit more lax about it until I realized that that is not technically correct. So I want to enforce that onto you guys before down the line someone else really harps on you for it.
Thank you.
Of course, that was a really great question. Okay, cool. Beautiful. So now we have, I just did in 3, we did multiplied 2 things together. Now I'm dividing 2 things together. We haven't talked about this quite yet, but this is called a rational expression, like a ratio. Rational numbers can be represented in fractions. Same with this guy. All right, cool. So what should we do first? Or what can we do first? There's not really one way. Switch the b's. So what I have, Jaden says we're going to switch the b's. So I'm going to have 6, a to the 5th. And then what power of b is going to be on top? Yep. And what about on the bottom? Perfect. Right? That's one way to start. Kind of get yourself on a clean state. So we only have positive exponents. Great. Someone that's not Jaden can tell me what we can do next. What can we do next? Yeah, combine like terms. So we combine like terms when we multiply, but how do we do it with division? CJ, can you explain that to me?
Do we subtract or?
There's some subtraction involved, but what do you mean by subtract?
Basically like try to subtract like I guess the like terms on the top from like
Yeah, so I think what you're trying to say is let's keep -6 and 2 kind of by itself, and then like a to the 5th -7 and b to the 3rd -1, like that.
yes.
Yes, okay. So I think what you're kind of saying is if I bring, let's do this step by step. If I bring a to the 7 up top, so it's like a to the -7th and b to the -1. And then can we all agree that -6 over 2 is -3? There's no like exponents going on with there. So then we get a to the 5 -7 and b to the 3 -1. So I get -3, a to the -2, b to the +2. Yes. Is this simplified? Jaden says no. Does anyone else agree with Jaden? Kara's in here. I can't help this.
No. I am trying to focus. I'm becoming a resident today. I need to focus.
Tucker, do you have anything to say?
You crash here sometimes. You gotta jump over.
I also too love Grey's Anatomy. So great. It's not simplified yet. How can I make this simplified? I have to move the a to the bottom, right? So I'm gonna have -3, that's fine, b squared, and then I'm gonna put a squared on the bottom, right? And remember, it changed from a negative exponent to a positive exponent because it wasn't happy up top. Now it's happy on the bottom. And then I would call that done. All right, I think we have one more example. And I'm gonna leave that in case someone is still writing. With the base change. The number can be negative, right? Just not the exponent. If I had like -3 to the -1, the base won't change. So if I had like, do a quick example, -3 to -2, 1 over -3 squared. The exponent's the only thing involved when you move it, not the base. Remember, that's when the negative is in the base. If it's not in the base, it's a totally different story. I'm gonna leave that up there actually. Can I reverse what I just said? Great, cool. Alrighty, so problem 5, you guys are gonna do by yourself and then someone's gonna explain it to me. So I'll give you like 3 minutes so you can like check your work. We have -3x to the a minus 5. Remember, x and a are just 2 random real numbers. Y also a real number. Y is raised to the -3rd, and then that whole quantity is raised to the 4th power, as you can see on the screen. So using the properties that we've talked about earlier, simplify this down as much as you got, and we will circle back at 5:07. And I expect you guys to be working, because I have an email to check. Okay, maybe we'll do like 2 minutes. Bum, bum, bum. I'll give you guys another minute and then I'll see if someone wants to explain. That's not Jane. Answer too many. Who else wasn't on to answer anymore? Ronald. Alrighty, we good to go? Or does anyone need a little bit more time to think? Give me like another 30 seconds. I thought about it. No. Because you don't get to know what the right answer is all the time. You just gotta take a leap of faith. Some life lessons right there. All right, cool. There are no wrong answers. Being wrong is just a step on the path to be right. Thanks, guys. All right, who wants to tell me how I can do this problem? Or I'm going to pick one of you. So Abby says distribute the 4 first, right? I can distribute exponents over the 5, not the multiplication. So when we say we're distributing, it's going to go to, oh my gosh, the 3, the x to the a minus 5, and also y to the negative 3. So that's going to look like, is it going to look like that, Abby? Or am I missing something when I write it with the negative 3? Is this correct? Careful, remember, I need that, it's negative 3, so I need to include that parenthesis. So it's not correct. So I don't think so. I think it was correct. So let's just keep parentheses on everything. So we're kind of making, I know I'm moving right now. We're making it look like this, kind of, in a sense, leaving a parentheses out there. So there's a 4 here, y to the negative 3 to the 4th, right? So I used property, I think 3, and now I'm going to use property 4 for these two guys. Negative 3 to the 4th. What's that going to be? It's going to be positive 81. Remember, it's going to be like negative 3 times negative 3 times negative 3 times negative 3. So it's going to be 81, or 9 times 9. So now I have x to the a minus 5 to the 4. So that's going to be x a minus 5 times 4. Remember, it's times the whole thing. No, you're fine. I drank coffee before last class on Thursday, and I was like up till 2 a.m. So don't drink coffee this late. Maybe like a nice tea. So I'm keeping a minus 5 in parentheses just so I know that 4 is multiplying it by a minus 5 is being multiplied by 4, that whole quantity. And then I'm going to have y negative 3 times 4. That's a little shorter, so I don't really need a parentheses. You could if you want to. I'm not going to judge your overuse of parentheses. It never hurts to overuse parentheses. All right, so 81 is 81. What's x going to be raised to now? Yeah, 4a minus 20, right? I just distribute, we know how to multiply over subtraction, just like that. So 4a to the 20, and then y is going to be to the negative 12. Beautiful. Are we done yet? Chloe, you beat me to it. Chloe says we need to move y to the bottom. She is correct because we are not done yet. So I'm 81 x to the 4a minus 20 over y to the not negative 12, positive 12. All right. I know you might be thinking about this negative 20. It's okay because 4a is still positive. There's still a positive out front. If both of those terms were negative, I'd probably say move it to the bottom, but we don't know what a is. A could be 100, or x would probably be okay to be on top. Yeah, I don't know what a is, and splitting up x into 2 things, so moving like, I can think because x to the 4a, hold on, let me make sure. Yeah, okay. And that would be like x to the 20. That's less simplified, right? I want to keep x to one thing, and since the way that I write these things is like my variables first, so like something with a random letter, we call those variables. I put those in front of my constants, negative 20. So fine with that, right? If you're ever confused about that, that's a quick question that you can always ask. All right, is that done? Are we done? Woohoo! Oh my God, great guys. Not done for the day, just done with, what was this, 8.3? What notes are these? 8.3, okay, cool. Does anyone need me to stay on here? These notes are always posted if you need to go back and catch up on something. Okay, cool. So now we're moving on to 8.4, which talks about radicals and rational expressions. A radical is this guy. That's a radical. The inside is the radicand. So if it's an AL, it's a crazy symbol, like integral. If you've ever heard of an integral, that, and then the jargon inside is the integrand. So ol is the fun symbol and is the inside. So that's a radical. If I don't have a number there, we assume a square root, just like Abby said. But, ooh, the trash guys came. I can put a 3 there. That's what we would also call cube root. If I have it in here, I would call that the nth root. And we'll get more onto that. That's just a quick notation that I was excited to talk about. Here, I'll leave these up. Those are all some different ones. Okay. Where are my notes for this? Okay, so we say if a raised to the n equals b, then a is the nth root of b. Right, just kind of like saying like that. All right, so if a squared is b, then a is the square root. What do you think about number 2? I think I've already said it. Right, it's a cube root. Those are the only ones that we have fun names for. There's no like hexagonal root. What's another fun one? Dodecagon, dodecagon, root, none of that. Septagon, those are pretty cool, 7-sided. And so forth. So square and cube are the only ones, 2 and 3. All right. So quick little notation. So if n does not equal 0, then we can say that a to the 1 over n, this is different than a to the negative n. So if I have a radical in the exponent, we say that is the nth root of a, and I would write it like this. So like a to the 1 over n equals this. Okay, don't get this confused with the negative n, right? This is 1 over a to the n. That makes the base a radical. Not a radical, a ratio, a rational number. There we go. This, the rational number, is in the exponent. Do not get these confused, okay? All right, coolio. Some quick examples. Some of these are square roots, cube roots. Roots are not really as intuitive. You have to think about how they were defined up here. If a is the nth root of b, a to that power is b. So 16 to the 1/4, I'm looking for something that raised to the 4th power gets me 16. So I would write this as the 4th root of 16. And does anyone have any guesses? It's 2. Okay, I didn't look. Yeah, it's 2. And then you can always double check. 2 to the 4th is 4 squared. which is 16. So don't always check yourself by going the other way. And I just kind of answered 3. Remember, if there's nothing on the radical, we assume that it's a square root. And I think we all know that from our times tables. Did you guys ever have to do like speed quizzes and knowing your squares and cubes? That's why I know like 250, 256 is like 16 or 17. Or is it 13? Anyways. 64 to the third. Oh, thank you guys. What did we plus or minus? Oh, thank you. Yes. Oh my gosh. Okay. I forgot to talk about this. When we have an even root, so there's technically like a 2 right here. These guys are evens. Thank you, Griffin. We have our plus or minus. The notes that I'm looking at are old, and they follow the textbook, and the textbook actually doesn't bring in plus or minus quite yet. But Griffin, you are correct. I only need it if there's an even number on my thing. That's because if I were to go the other way, right? So -4 times -4, those negatives cancel out, and that's how I get positive 16. But for 64, the cube root, was that 3? 64, I think that's, is it 8? No, it's 4. Yeah, 8 times 4. That's only positive 4, because if I did -4, why are you not freaking out about the garbage man, dude? Only 2 of the negatives cancel out, so I'm still left with a negative there. So odd radicals, that's gonna leave you with a plus, only the same thing that's on the inside of the radical. So if there's a negative, yeah, I can -64, the cube root of that is -4. We just saw that right here. But since this is positive, this answer is positive. That only works for odds. Even ones, plus or minus. Does that make sense? So if I have an even radical, I have an even number of answers, 2 answers. If I have 0 is not an option. If I have an odd in the radical, remember in the radical, I'm talking about like that little number. I'm gonna have an odd number of answers. 1 answer. That's a good way to think about it. Just came up with that on the spot. How much time do we have? I have 20 minutes. Oh yeah, freak yeah. Okay, cool. And we actually talked about this last class about like what's a rational number. Again, wait, what's 20? Oh, thank you. You want me to explain the plus or minus thing again, Chloe? Yeah. So when we're talking about it kind of back into this context of A is the nth root of B if A to the n equals B. So when I have an even number of negative numbers, all the negatives are going to cancel out, right? So if I have -2 to the 5, -2 times -2 times -2, which is going to be 4 times 4 times -2, which is going to give me -16. It's a denominator of the exponent. You need to be careful with explaining that, just because it could get, when I think of denominator like that. Yeah, so if this n right here or right here is even, you need a plus or minus. Okay? And we'll talk about in cases when I have not a 1 right there. Okay. And if you're still a little confused, that is what homework is for, to help solidify that confusion. All right. So we talked about rational numbers a little bit last time, but it has the word ratio in it. So ratio is just something over something else, right? So rational numbers are anything that can be represented as fractions. So any whole numbers I can just write as like 3/1. That's also just 3. So any number that I can be written as a ratio, but I can't have like 3.3 repeating. Well, that's okay. That's a fraction. What's a real number? Pi. Pi is repeating and it's not a fraction. Over, what's another number? 2. That is not a rational number. These numbers need to be whole numbers. And we'll talk about rational numbers more and rational expressions. Okay? Using properties. Okay, so using properties of exponents, we can define rational exponents. So first time, I know I'm moving around a lot. I just talked about 1/n. But what if it was a to the m/n, right? Any rational number, a fraction, if you will. Well, I can think about it in 2 ways. I can think about it using what we just learned earlier in class. I can think about it as like a to the m to the 1/n, or I can think of it as a to the 1/n raised to the m. If you are dealing with actual numbers, this is kind of the best way to go and make a number small and then square it. I don't want you guys to find like 9 cubed and then take the square root of it. I don't know what that is. Sometimes it's better to make a number smaller than bigger again. And I will show you what I'm talking about in a second. Okay, there we go. I had to remember what I was talking about. Whee. So now I have, here, let me see if I can fit this all in here. There we go. So our first example is -8 to the 2/3. So I can either write it as -8 squared. I like to change up which brackets I'm using, to the 1/3, which is also the same as, or I can do it like that. Those are all equivalent. It's just kind of up to you which one you guys would want. I usually like to do I think I would actually square it first. No. Let's do it. Let's do the bottom one. So what do you guys think the cube root of -8 is? Right, it's -2. Right, remember, so if it's an odd number, that negative is going to be in my answer. So it's going to be -2 squared. And -2 squared is just what? What is -2 squared? Okay, everybody, we have 15 more minutes of class. 4, it's +4, right? The 2 negatives cancel out. So it's going to be a +4. Let me crack my back, hold on. Oh, sweet. Okay, cool. How can I double check that the cube root of -8 is -2? What's a way I can check myself on that? Yeah, I can cube -2. Okay, calculators are not always allowed. And sometimes it takes you longer to do something on a calculator when you should just know and do it in your head. That is a life lesson from someone that has worked in an office. I can double check it by doing -2 cubed. Remember, -2 is my base here. Ronald also has that calculator. I want to include that -2 in my base, or else I'm checking the wrong thing. Right, and -2 times -2 times -2, 4 times -2. Great, I get -8. So I get back to the radicand. All right, great. So number 2 is kind of the one I was talking about, where it's better to do the radical first and then the power. So what I mean is that it's easier to do the square root of 9 cubed than it is to cube 9 and then take the square of that. First of all, I don't know what 9 cube is, and I definitely don't know the square root of it. So square root of 9 is going to be what? Griffin, you want to get your own answer that you told me earlier. It's not just 3. That's only one of the answers. Plus or minus. Right? So I have 3 and -3. And I'm cubing it too. So can I keep that plus or minus when I'm cubing it? Yeah, because it's an odd one. So whatever sign is going to stay there. So 3 cubed is 27. And -3 cubed is -27. So if you want, you could have written it like 3 cubed or -3 cubed. And then you would have gotten 27, or that's not 2 to the 7. That is 27 or -27. That's the same as saying plus or minus, just a different notation. All right. So both of these are saying the same thing. All right. Well, now I have a negative rational exponent and I have a rational base. Tricky, tricky. What can I do first? Ah. Could we combine them? What do you mean by combine them, CJ?
Well, since they're like the same, like A's are the same, and then they have the same denominator, so like, can we just like
Can you say that again a little louder? I'm sorry, I'm hard of hearing.
since you see how A is the same, and then 1/3 and 7/3, they both have the same denominator. So couldn't we just like make it like A to like A/3, or no?
What do you mean by A?
Wait, for
For 3.
for number 1, right? For right here.
Oh, we're doing right here. We're right here.
Oh,
You were a little ahead. So, no, you're fine. I'll let you answer that question when we get there. So, what I would do is I actually, since I hate negative exponents, I am going to apply the negative to 32 or 1/32 first. So, I'm going to do 1/32 to the -1 to the 3/5. What is that -1 to do to 1/32? It's gonna flip it. Careful, exponents don't make things negative. Yeah. So I was thinking for a second, right? When I have a negative exponent, it flips it. So instead of 1/32, it's gonna be 32/1, which is just 32. I hear you, Pop Pop. So I get 32 to the 3/5. Great. Got rid of a fraction for me, which I also hate fractions. And I got rid of another, the negative exponent. I also hate negative exponents. So now I have 32 to the 3/5. What can I do next? How can I simplify this a little bit more? What radical, Ronald? Cube isn't a radical. So remember, the 3 is in the numerator of the exponent, so it's not going to be a root at all. So if we want to do a radical first, I would do 32 to the 1/5 cubed equal, so I could write it as like, there's my 5, 32 cubed. Does anyone know what the 5th root 32 is? Right. An anonymous caller gave me 2. Right. Is it plus or minus 2? Or just 2? Yeah, it's just 2 because that's an odd number. 5 is odd. Right. And then I have 2 cubed, which we all know is 8. Right. We have like 6 more minutes. Okay, cool. Alrighty, let me see what else we have in this section really, really quick. Oh my gosh, we just have a few examples. Alrighty. We have 6 more minutes. I think I'll use these guys as a way to help us review for next time. This is one of my favorite problems. But the only difference between these guys and these guys is I don't have as many numbers. I have lots of variables now. Alrighty. How do you guys? You guys all, what do you mean due dates? Every Thursday is a homework day, always. Unless otherwise like said, you'll always have a homework due on Thursday. This week it's just a practice homework that you don't need to turn in because you guys are kind of slow about joining WebAssign. So next Thursday, you do have something due to me. All right. So last 5 minutes of class, let's do this Socrative counts this time. So I moved my teacher Socrative away from my student one, and now I cannot find it. Also, do not fill anything out right now because I don't think I closed the last one. There it is. It's okay, bud. Oh my God. Hi. I know you want to go on a walk. Finish. Okay. Thank you, Abby. Right, remember our room number is my last name in all caps. And in numbers are 9, 4, 3. Do last name, comma, first name. The first question asks you how you understand today. Second question asks you what we learned. And your teacher question of the day is what is -9 to the 3/2? Did we do that problem? We did that. Don't do that problem. Not the teacher question of the day. 2/3. If you're writing on my board, I will be very mad. And then once you guys finish your exit ticket, you guys are done for the day, and I will count that as your attendance. Exit slips are on an app called Socrative Student that we've been working on the last 2 days. It is an app on your phone, and it also is a website. The website is just Socrative.com. So the app is Socrative Student. And you don't need to create a login or anything. You just need our room. And then it will ask you your name. Remember, you need to complete the exit slip for it to count. I know. I'm expecting you guys to do this without your calculator, by the way. That isn't really a whole number. Well, I always do like 2 or 4. How many ever ones you want to, Ronald? Actually, you do need a calculator for this one. This is what I get for going on the fly. But I can't take this back. My bad. Really, only 28 out of 37 of you. Duke, stop. As many decimals as you want. I always do like 2 or 4 decimals. That's just a personal thing. Don't give me like 20. Should have done another number. That was a bad number. Once you guys are done with your exit steps, you are free to go. If you have any questions, I'm gonna be here for a little bit. As always, the notes are posted right after class, and so are the videos. Remember, you need to complete the exit slip for it to count. Just entering your name does not count. I can see your answers. Thank you, Jaden. I'm going to stop recording.